in the name of God. Hello, dear students. My name is Masoud. I'm a physics teacher. We are here in Ferhua's website to explain physics curriculum for you. We have a plan to make the physics easy for you. Right now, actually, I'm going to solve the practice 1F for you, page 16. So far, we talked about tangential acceleration and its relationship with angular acceleration. I solved the sample problem for you. Right now, I'm gonna solve the practice 1F, page 16. Right, let's get started. Let me read the question for you. Question number 1. A child on a merry-go-round undergoes a 1.5 meter per second square linear acceleration. Linear acceleration within the circular track is called actually tangential acceleration. Teacher, how do you know the motion is circular track? Because it talks about the merry-go-round. And merry-go-round rotates, right? And it creates a circular track for the objects above it, right? So AT is given. If the merry-go-round's angular acceleration is, what's this? Angular acceleration alpha, 1 rad per second square. How far is the child from the axis of rotation? How far? It talks about the r. How far is the child from the axis of rotation? This is a merry-go-round. This is the axis of rotation. And this is a child, for example, right? In a certain distance from the axis of rotation. So the distance between the child and axis of rotation is called radius. We look for this number, right? So I summarized the information in this box actually. AT is given 1.5 meter per second square. Alpha is 1 rad per second square. We look for r. Actually, we use this rule, r is equal to AT over alpha. Maybe you say, teacher, where does this rule come from? What's the origin of this rule? This rule comes from the main rule. AT is equal to r alpha. I want you to rearrange this equation for r. So r will be AT over alpha. Cool? So it's not the new rule, it's a rearranging for a relationship between tangential acceleration and angular acceleration. Just substitute the number and find the answer. AT is equal to 1.5 divided by alpha 1. And the answer will be 1.5 meters. That's it. Right? Question number 2. Let me pull it up for better vision, actually. Question number 2. Let me read it for you. What's the tire's angular acceleration? What's the tire's angular acceleration? So we look for what's the tire's angular acceleration? We look for alpha, right? Alpha. Angular acceleration means alpha. If the tangential acceleration at a radius of, this is r, 0.15 meters, is 9.4 times 10 to the power negative 2 meter per second square. And this one is AT. All information are available for finding the alpha, actually. And I have a question for you. Are, let's say, dimensions unified or not? Of course, dimensions are unified. It doesn't need any conversion. Just write the equation, alpha is equal to AT over r, and substitute the answer. Substitute the numbers, that's it. AT, 9.4 times 10 to the power negative 2, r, 0.15, and divide this number by 0.15 to find the answer. And the answer will be 0.63 rad per second squared. That's right. I included an extra question, which is a question of national exam, right? The first part is completely different from this question, actually, from the previous question. But the second part of this question, of extra question, it looks like, let's say, question number 2. the second part, right? Let me read the a new question for you, and it's not in our actually in our practice, but it's the question of national exam. Let me read the question. A disk starts from rest. What does it mean? Means alpha is equal to, means omega I is equal to 0. I mentioned it, right? After a while, after 4 seconds, so delta t is equal to 4 seconds, its angular speed is 2 rad per second squared. 2 rad per second. So it speeds up, right? It speeds up to 2 rad per second. Calculate the tangential acceleration. So we search for tangential acceleration, or AT, of a point on the disk that is 0.1 meters from axis of rotation of the disk. So r is equal to 0.1 meters, right? So here we look for 80. I have a suggestion for you. Ignore this information as if there's no tangential acceleration in this question, right? Just focus on these information, omega I, delta t, omega f. And I want you to find alpha for me. So ignore AT and R, right? We don't need them till now, actually. Right now, we don't need them. If we focus on these information, let's say, think about the kinematic equations with constant angular acceleration. For equation, right? We had 4 equations. I want you to, let's say, think about these equations for finding alpha. Omega I, delta t, and omega f. So look for the equation that involves this information. Which one, let's say, involves this equation? This equation. Maybe you say, teacher, we haven't seen this equation before, and let's say there's no, let's say there's not this equation. This equation is not, let's say, in our in for kinematic equations, but I'm gonna, let's say, make it easy for you. Where does this rule come from? Actually, it's not the new rule. It comes from this equation. Omega f becomes omega I plus alpha delta t. So it's one of the kinematic equations, right? Rearrange this equation for alpha. That's it. That's why it's not a new rule. It's just rearranging for this equation. Omega f is given. So alpha, after you wrote the actually after you wrote the rule, I want you to substitute the numbers. Omega f becomes 2 minus omega I becomes 0. 2 minus 0 divided by delta t becomes 4 seconds. That's it. 2 minus 0 becomes 2. 2 over 4 becomes 0.5 rad per second squared. Are we done? No. Because it says find the tangential acceleration, AT, not alpha. We found, actually, we have found alpha already, yeah? We've already found alpha, but we have one more step, actually. It takes one more step. AT is equal to R alpha. Right now, let's say, focus on the part that I told you ignored. We ignored it at the beginning of this solution, but right now, after we found actually alpha, right now we use it by this equation. Actually, you can find AT is equal to R alpha. R is equal to 0.1 meters multiplied by 0.5, and the answer will be 0.05 meter per second squared. That's it, right? We have one more, let's say, extra question that looks like this question, actually, right? And this question is a question of national exam as well. Both of these, let's say, problems are questions of national exam. Let's say, focus on these problems. They are important. And let me, before I move on to the new question, let me choose the correct answer, right? Let's circle the answer. we have 4 options in national exam question. So we found 0.05 meter per second square. This one is the answer of our question. Let's move on to another question. And I told you this question is the question of national exam as well, like the previous question. Let me read it for you. It says if the radius of a car tire is 0.3 meters, what's this? This is R. Rotates at an initial angular speed of 14 rad per second. This is omega I, because it doesn't say it starts from rest. That's why it's omega I, initial angular speed, omega initial. The driver accelerates, and after 3.5 seconds, this is delta t. You see it. I can say it looks like the previous question. Let's say, except for some numbers actually, except for some numbers that are not that are changed actually. The numbers changed, so we have the same. Let's say procedure. We have the same process, and let me complete our subject. Let's keep going. The tire's angular speed will be what? Will be 28 rad per second. So this one is omega f. What's the tangential angular? What's the tangential acceleration? You see, we look for tangential acceleration like the previous question. I can see they are copy paste of one another. Of a point at the edge of the tire. Like the previous question, I told you, ignore two information. Teacher, what information shall we ignore? Let me tell you the information. Yeah, you have to ignore it. R and AT. Focus on what? Focus on omega I, omega f, and delta t. Which equation? Go over it. Which equation involves omega I, omega f, and delta t? To find alpha, this equation, alpha is equal to omega f minus omega I divided by delta t. Omega f becomes 28 minus omega I becomes 14 divided by 3.5. That's it. So subtract 14 from 28 becomes 14 divided by 3.5. And after that, you get, let's say, you find the number, which is 4 rad per second squared. This is the, let's say, angular acceleration. Are we done? No. Because, let's say, we are asked to find tangential acceleration, not angular acceleration. That's why the second step is essential. AT is equal to R alpha. AT is equal to R. Actually, I summarized this information for you. 0.3 multiplied by alpha 4. And the answer will be 1.2 meter per second squared. This is the last answer. Let's circle the correct number. So B is the correct answer. That's all, guys, for today. I want you to follow our next videos on our application. The name of our application is Ferjuan's application. And thank you very much again for watching this video, and bye-bye.